So today we have Levin Nock. Levin works as a project manager in Bonneville Power Administration's Energy Efficiency Emerging Technologies Group as an aerotech contractor. His research projects support broader adoption of LED lighting and advanced lighting controls in the Pacific Northwest. Before joining BPA, Levin worked as an analyst at Pike Research, division of Navigant, where he wrote several special reports on energy efficiency in commercial building and interviewed more than 150 experts in the high-performance building industry. Prior to that, he worked as a project manager, a research engineer at a few startups, and 11 years at Siemens in product research and development. He has a bachelor's degree in physics, a PhD in biomedical engineering, and a certificate as a sustainable building advisor. Levin, as you will hear, is excited about LED retrofit kits for Troffers. And so now I will start and hand it over to Levin.
Thanks, Mike. So today I'll address four main questions about LED retrofits for Troffers. What are they? Are they any good? How do you find them? And where can you use them? So we'll start off with, what are they? In the center, we've got two views of a typical 2-foot by 4-foot fluorescent light fixture or ceiling troffer. The upper photo shows it in the ceiling. The lower photo shows it out of the ceiling, standing up on one end with the lens off, and 3 4-foot fluorescent lamps inside, plus 2 electronic ballasts. When an existing building already has a bunch of these in place, there are two ways to convert these troffers to LED lighting. First, there are linear replacement lamps shown on the left. These are shaped just like 4-foot linear fluorescent lamps, and they use the same lamp holders as the old fluorescent lamps that they replace. Most LED lamps like this have the LEDs all on one side that look like rows of little yellow dots. A few of the newer LED lamps have a translucent cover, so you don't actually see the LEDs. And a few lamps even send light out in all directions, instead of just one direction. Besides lamps, there are also kits, shown on the right. Most kits replace or modify the old lens, and they're designed to get the best light distribution from the LEDs. Ballpark prices for lamps are over $50 for each lamp, and for kits, over $150 per kit. But those are rough numbers, and they're changing every month, so it's worth checking your actual prices. There are hundreds of different LED lamps available. They fall into 3 main categories based on where the driver is. As you know, a fluorescent lamp needs a ballast to convert line voltage into the right voltage and current to drive the lamp. An LED lamp has a similar little transformer box, but it's called a driver instead of a ballast. Some manufacturers of LED lamps provide an external driver that looks just like a ballast. Others put the driver inside the lamp, so then the AC line voltage gets wired directly to the lamp holders. A third option is that some manufacturers actually reuse the existing fluorescent ballast. So in that case, there's no energy savings, although you do have new LED lights. So here are some pictures of a few kits, as opposed to lamps that I was talking about before. These are the kits. There are more and more products like this available, where the retrofitted troffer looks like a brand new LED troffer, but the back of the troffer is the old one that was already in the ceiling. Back in March 2013, there were 5 manufacturers of these kits on the Design Lights Consortium list. That's the main list of LED lighting fixtures that I'll talk about more later. Now, in early July, there are 10 manufacturers and 80 products, so it's growing really fast. These are the 10 manufacturers at the moment, and next week there'll probably be more. Most of these kits use a new lens, but some reuse the old lens. And some reuse the old lens, but also add a diffuser, so the combined lens plus the diffuser works better with LED, provided that the diffuser fits right and it's installed right. So that's what they are. Next, are they any good? Well, that's a kind of complicated question. Here are a few things that mini LED lights are good at. You've probably heard they last a long time. Nobody's quite sure how long, but there are credible claims for 100,000 hours and higher. It seems likely that in many cases the LED driver electronics will probably burn out before the LED light source dies. Recently, some manufacturers have gotten really good at rendering colors the way people like them. For instance, a retail store might sell more products if their lighting provides bright, deep, saturated colors that LED does really well. Some LEDs do really well, I should say. You can find poor products too, but you can find really good ones. Also, if somebody wants advanced lighting controls, such as dimming, high-level lighting, and daylight harvesting, LED lights might work really well and be comparable in price to fluorescent lights with dimming ballasts. Unlike fluorescent, LED lights do not mind being switched on and off a bunch, and when they're dimmed, their long life gets even longer. So a few years ago, it was hard to find products that had good color rendering, a choice of color temperatures, and were bright enough. That's no longer the case. There's a broad selection of products now, although you might still find inferior junk if you're not careful. You can pick a product that delivers the brightness you need, and you can probably find a product to deliver that brightness with a relatively low wattage to save energy. There are still some concerns with safety, so I got a couple of slides on safety. The Pacific Northwest National Lab recently completed a report on LED Troffers and Troffer retrofits as a CALiPER report for the Department of Energy. Of all the lamps and kits they tested for retrofits, half of them would have failed a safety inspection, mainly because of poor instructions and labels. So if you start selling these things, please make sure you pick a product where the instructions are clear so you don't create safety hazards without knowing it. For linear LED lamps, there are some safety concerns about the lamp holders. Most linear LED lamps are designed for power at either one end or both ends with either shunted holders or non-shunted holders. If you install the wrong lamp with the wrong lamp holders, it might not light or it might burn out. And the instructions might not necessarily be clear about all that. LED lamps are typically heavier than fluorescents, and that's especially true for LEDs with internal drivers. Lamp holders are designed to hold the weight of fluorescent lamps. That's their job. Some were probably over-designed and so they'll manage the extra weight okay, but others might not. The easiest way to avoid these concerns is to use kits when you can. That way, you don't need to worry about old lamp holders, and you don't need to mess with installing and wiring new lamp holders. So here are some questions to ask the manufacturer for any LED Troffer retrofit product. Has the product been tested by a nationally recognized testing lab for the proper UL test? There's one test for external drivers, and there's an extra test if it has an internal driver. Are there limits on the Troffers that are compatible? Like, does the Troffer need a certain depth to fit everything inside? And if it's an LED lamp, what kind of lamp holders does it need? Now, you might not have complete control over the maintenance procedures that will be used 10 or 20 years from now to replace these things. You cannot necessarily present all the things that might go wrong. But if you apply the right labels, then at least you're giving somebody a chance to do the maintenance properly if they want to. In addition, if you pick a product that does not need line voltage at both ends of the lamp, then you reduce the risk that somebody could get electrocuted by touching both lamp holders at once when the switch is energized. So here's a summary of product selection in terms of safety and energy savings. At the top of the list, kits are best because they're safer to wire and you don't mess with lamp holders. After that, lamps with separate drivers are pretty good because they're safe to wire, and the lamp holders are not expected to do much that they were not designed for. After that, going down the list, there's single-ended lamps with integrated drivers because at least you cannot touch the two energized lamp holders with your two hands. After that, there's double-ended lamps with integrated drivers. The only good thing about them is that, like all the other ones I've mentioned, if you pick a good product with a low wattage, then they save energy. If an LED lamp reuses the existing ballast, then it's probably safe, but it probably does not save any energy. So there's no incentive for energy savings. I should mention that at the moment, in the present BPA lighting calculator, these are all non-standards. The new lighting calculator that comes out this fall will have a more integrated in the calculator. So you probably will not need a non-standard incentive once the new calculator comes out. Continuing on the question of whether they're any good, we come to light distribution and glare. So fluorescent Troffers are designed for fluorescent lamps, enough, that put out light in all directions. Over the years, some troffer manufacturers have gotten pretty good at redirecting the light that goes up. So there's lots of light coming down in a nice bat wing pattern of light levels like the one shown in black. So if the troffer is at the center of this pattern, then you can see it spreading it out to the sides. So that means you can space the troffers farther apart, and they still provide uniform light. LED lights, on the other hand, are very directional, and most linear LED lamps only have LEDs on one side. That means they point straight down, and the fancy reflector up above the lamp is useless. So the light level under a troffer with new LED lamps looks more like a blue circle. That's great if you've got a workbench directly underneath the troffer and you want all of the light dumped right there. But it's not so good for creating a uniformly lit area unless you have troffers that are already spaced pretty close together. Again, most LED kits address this challenge better than most LED lamps because the optics of the kits are designed around LEDs. Still, some of the newer lamp designs are pretty good, where the designers really took the time to make a product that spreads out the light for a more even distribution. If an old acrylic diffusing lens is reused with LED lamps, or with a few of the LED kits that did not provide a new lens, then the light distribution is likely to be uneven. You get a bright stripe of white light under each row of LEDs with stripes of gray between the rows. When a multi-lamp troffer has been de-lamped, then you really notice the gray stripes. Here are some examples from the CALiPER troffer study. These uneven patterns in the lenses tended to feel less comfortable and more glaring to people. On the left, here's an example where an old 3-lamp fluorescent fixture was de-lamped down to 2 LED lamps. You can see where each row of LEDs points down really bright, but the spaces between the LEDs are gray. On the right, here's an example where an old parabolic louver was reused with bare lamps. This painted white stripes of light and weird shadows on the walls, as shown on these cupboard doors. So if you need to add LEDs to old parabolic louvers, the best choice is a kit that simply replaces the louver. Just get rid of them. Short of that, you could choose a kit or lamp with new diffusers, so the diffusers spread out the light from the LEDs before it hits the louvers. Otherwise, you get glare and stripes and sharp shadows that people tend not to like. In the CALiPER study on LED troffers, they concluded that for visual appeal, people preferred a light source with a good diffuser, or else a combination of a lens with a reflector. Smooth white panels with uniform brightness were also okay, but less exciting. They don't look, new and great like you've got the latest LED thing. The losers were the ones with contrasty patterns between bright spots and dark spots. Continuing on our overview of quality in LED troffer retrofits, we come to flicker. You may recall that old magnetic ballast T12 lamps flicker at 120 Hz. Some people notice this more than others, and some people get headaches with long exposure. A few people can actually get seizures that are dangerous, and there can also be danger around machinery if a moving part looks like it's moving more slowly than it really is, or it might look like it's standing still. This problem with early LED fluorescent lighting was solved when electronic ballast came along with a flicker rate that's well over 10,000 Hz. From what I've heard, anything above 1,000 Hz is probably safe in terms of health. For lower frequencies, there's some concern, so then it depends on more details besides just the frequency. Some LED lights flicker all the time. Some only flicker when they're dimmed, and some LEDs do not flicker at all. And that flicker frequency may be all over the place, from relatively low, like 120 Hertz, up to 500, 800 Hertz, or 10,000. There's no standard test yet for flicker, and there's no standard measurement to report on the product labels. In the meantime, until they get a standardized measurement on the labels, here are some different ways you can check it for flicker. First, make sure that the only light source is the one you want to check. If there's daylight or incandescent or other light sources in the area, then you might not see the flicker, even if it's there. One simple way is to wave your finger and hand back and forth beside your head and notice if there's any stop action artifacts, like a strobe light. Another way is to point your cell phone camera at the light source. If there's flicker, then you'll probably get strange looking bars of light that are not really there, like the two photos on the left. If there are no stripes and you only see the light itself, then there's probably no flicker. Probably the best way to check is to use a flicker checker, which is a little spinning top. Sylvania makes them as a way to find old magnetic ballasts. You spin it, and if you get a smooth gray pattern, then there's not much flicker. If you see any strange, unexpected patterns, then you've got flicker. So here are some examples. If you look at the top row of charts here, on all of these charts, the output in terms of light is on the vertical axis. So they're all normalized. 0 down at the bottom means there was no light output, and 1 at the top means that's as bright as that light got. And so then these are charts over a time scale of 100 milliseconds. So these are some different examples from the CALiPER Troffers study. This first row shows what it looked like when it was switched on. So then you have a value of 1. And then they turned it on with the dimmer set at 100%. And you can see the value is also constant, but a little less than 1. And then they turned the dimmer down to 25%. And you can see the actual light went down to 20% or 0.2. And so that's pretty much the performance you would expect and that you want from a light. The next one, W, it did almost the same thing, except if you look over on the right-hand side, it dimmed down to about like 8% instead of 25. So it kind of missed there. The next one, X, you can see there's flicker. And so when it was dimmed, when the dimmer was set at 25% over on the right, there's 250 megahertz flicker. And so that's in the debatable zone where, you know, it's kind of up for debate in terms of exactly the shape of the flicker and how many people that might notice that. Here's another one. Row L actually looks a lot like a magnetic ballast. Even when it's on the switch, not even trying to dim it, it still has about the 21% flicker. That's actually probably a little worse than a old T12 magnetic ballast. And that's at 120 hertz. So, and then this M one down here looked fine when it was switched or at 100%, but then it had a whole bunch of flicker at 460 hertz over on the right when it was dimmed. So all of these charts were from products that were produced about a year ago. They were bought a year ago. So even if you went back to this study and checked the product names, these manufacturers may have modified it by now. And there's lots of other products out there. And so manufacturers are addressing this issue. There's just no, the labels haven't caught up yet. So there's no easy way to check the number on the label and see. So you're back to your flicker checker for now. So next we're on to controls. In theory, dimming LED lights works great because LEDs are okay with frequent switching. They don't mind being turned on and off a lot. And usually when you turn down the brightness, that corresponds with low power. So you can turn down the power to say 10% on some of them and still get 10% light. But in practice, before any large installation, you need to be sure to mock up the circuit with all the components because at this stage of the game, things are not necessarily all compatible. So you want to try out all of the switches and all of the lights and the configuration, like, you know, how many lights you want on each circuit for each control, and try it all out and just confirm that everything works and you don't get weird flickering or something unexpected before you build out a large installation. Eventually, I hope this will all get standardized, but it's not there yet. So I haven't mentioned yet the question of, well, why would you go for LEDs instead of fluorescent? It turns out the fluorescent price is hard to beat. So, and that's true. And those LED kits that I showed, you can get new fluorescent retrofit kits that look just like that. So if you just want the new upgraded look, You can also do that with fluorescent. There are a lot of high-performance T8s don't have as long a lifetime. They're like maybe 30,000 hours or 50,000 hours, but you can find them with longer lifetimes, like 80,000 hours up to 100,000 hours. But one difference is, though, when that lifetime is defined as 100,000 hours, that means that at 100,000 hours, only half of them will have burned out. So that's kind of a different definition from LEDs, which is if the LED claims 100,000 hours, the chances are pretty good that most of them will still be running, or they will just have dimmed a little bit. So the other question about fluorescence is some of these LEDs don't actually save much energy compared to a 28 watt HPT8 fluorescent. And when you're talking about a $5 fluorescent lamp versus a $50 LED lamp, it can be a kind of a difficult argument to make. So I want to acknowledge that fluorescent lamps are still alive and kicking. So this chart kind of summarizes some of the issues that I just talked about for lamps and kits. In general, kits have fewer concerns than lamps. And in terms of energy saving and figures and controls, they both have some concerns that you really need to check. Well, what is the wattage? For energy savings, just look, what is the wattage of this particular product? And is it going to save me energy? Because there's a broad selection. So, where do you find them? There's a couple of main lists. The main list for finding LED lighting fixtures is the Design Lights Consortium Qualified Products list. And there are also two others, the Energy Star list. Energy Star checks mainly residential lamps. But when some lamps, there are some lamps that are used in residential and commercial zones, and so in that case you may be able to find an Energy Star rating. But for these Troffers, 4-foot long linear fluorescent Troffers that I've been talking about, Energy Star does not have anything. There's also the Lighting Design Lab, which is a regional list that has a few more products. But the main list, with I think it's over 20,000 products now across all LED lighting fixtures, is the Design Light Consortium. So I usually get to it by simply Googling on Design Light List. And then you get to designlights.org. And then you can find an Excel spreadsheet that will list all of the different products they have available. And then you can search by product category. Now, I should say that, so these are all the product categories now that are lamps and kits. Now this is a little confusing because if you look under the lamps, you can see that there are lamp style kits. And then below that, there are kits. So when I've been talking about lamps, I've been talking about linear replacement lamps and lamp style retrofit kits. Fortunately, that confusing term, lamp style kits, is going away. That will be obsolescent. I'm not sure. I think later this year it might go away. And then all the lamps will really be called lamps, and then it will be simple. But if you go to the Design Lights Consortium website and you don't find this in a few weeks, it may look more like this because they're doing a major upgrade on their website. And so then you will be able to search for products based on things like the light output, the efficacy, the wattage. So you just dial in what it is you're looking for, and then that'll go through that spreadsheet of 20,000 products and find the ones that are what you're interested in. So if, yeah, I'm not sure exactly when this goes live, but I believe it's in a few weeks. The other option besides the Design Lights Consortium I wanted to mention is the Lighting Design Lab. And not only does the Lighting Design Lab have their own list with a few hundred products, but they also have a nice link to Energy Star and Design Lights Consortium. They're down there at the bottom of their page. So, next question, where can you use them? Well, one place is in retail. You can get LED lights now that are really bright, and they have a high color rendering index, and they can accent the red colors. Turns out in retail, a lot of stores, when they have a big sale, they might have red colors. Valentine's Day, you really want to see the red. They want colors that punch. And some LEDs are really good at this now. Another place I've heard them being installed is in offices where someone might put high-performance T8s in the back offices, but in the front public conference rooms where they want to impress people, they put in LEDs with the new high-tech look. At this point, they still cost a little more, so maybe they don't put them everywhere. Another option is with computers. A lot of offices don't need as much light as they've got now. So if you install, you can pick a kit with a relatively low level of light, and people still have plenty of light to see their computers, as long as they've got a task light for the times when they want to read a paper as well. So that's another place where it can work well, and you can install a really low wattage per square foot. Another place, because they have long life, is difficult access. No, if it's really hard to get up to these places to replace the lamps, then waiting a long time till the next one is a good idea. And if a place wants advanced controls for daylighting, photo sensing, occupancy sensors, they want scheduling, there's all kinds of fancy things you can do with the controls. If somebody wants controls, then LEDs and fluorescents are pretty comparable in price, because the dimmable ballasts are more expensive than the regular fluorescent ballasts anyway. So that's what I've talked about. What are they? Lamps and kits, two main categories. Are they any good? Well, it depends. As I hope you understand after I went through all of this, it depends a lot, and there's a bunch of questions to ask. How do you find them? Mainly on the Design Lights Consortium list. And where can you use them? If you need a choice of brightness, if you want a high-tech look, or if somebody's just excited about LEDs. And so these are some references that I've used. There was a CALiPER exploratory study from Pacific Northwest National Lab, and then Naomi Miller did a webcast last month based on that study. Also, Bonneville Power has recently posted 11 case studies on LED lighting, so you can see some of the ways that people are using LED lights in our region, and there are a few of them on lamps, actually, lamp retrofits for Troffers. BPA also has a 5-page brochure with kind of the highlights from this webcast that is posted online, and I'm pleased to say if you simply Google BPA LED Troffers, you will find it. And last but not least, Micah Rose gave a presentation in this same series 2 weeks ago that was really a good foundation for LEDs in general. So if you missed that, I would recommend going and catching that as well. And so where that is on the Northwest Lighting website. There are a whole bunch of trainings coming up after this one. I think there's a few more webinars and then some in-person ones as well. And I'm done. So I think we'll open it up now for questions.